Fordham here, and we're going to be talking today about simplifying radicals, but with variables only. And you might be confused because I don't have a single radical on my screen right now, but that's with intention. What we're talking about here is exponents specifically with this stuff. I just wanted to do a little refresher on exponents. And there's some terms that you might need to just touch upon again to make sure you fully understand them. So right here we have a term. And we know we have a term because there's no adding or subtracting signs, a term that's usually how they're separated by. And there's three parts to this term. So we have right here, the first part, the 2, is the coefficient. That's the number in front of the variable, coefficient. It's been a while since I've had to spell. So we have that. Our variable right there is the letter in the problem. And that's the thing that can change every time. And the last part is the exponent. And what we're going to key on today is the exponent. We actually don't even really care about the coefficient today. That's not a major concern of ours. What we're really worried about is the variable and the exponent. Now, something to remember about exponents. Another way to rephrase it, it's known as repeated multiplication. So the actual operation associated with exponents is multiplication. So for instance, looking at the first problem I have written down, I have x to the third. So that means I'm actually going to take the variable. Sometimes it's also referred to as the base, by the way. I should throw that in there. And that's how many times I'm going to multiply it out. The exponent tells me exactly that. So I had x to the third, which means I'm going to multiply the base 3 times. 1, 2, 3. So in our second example, we have a base of 4 and an exponent, or a base of h, base of h and an exponent of 4. So that means I'm going to multiply it 4 times. I better have 4 h's. 1, 2, 3, 4. This is a little trickier, p to the 0. Now, you may have heard this before, you may not, but let me at least refresh / be the first to say, all exponents to the power of 0 equal 1. No matter what. This could have been 7,000 to the power of 0. It equals 1. And we'll talk more about that in an exponent video later on. But just if you see a 0 as an exponent, you should immediately think it equals 1. And the last one, w. Well, kind of like sometimes you may have heard that in front of the w there's a ghost 1. Well, there's also a secret exponent if there's nothing written of 1. So we could really write this as w to the first, which would just mean we have w. It's nothing fancy. All right, let's apply this to square roots. So here we have simplify the square root of x squared. Now, the previous video we learned a little phrase called couples go out and singles stay home. And we're going to work with this phrase even more today. It's just easy to remember, and it works really well. All right, what I'm going to do is I'm going to take the exponent set up here. I've got the base and the exponent, and I'm just going to write it out the long way. So I've got x times x. Well, we learned in a previous video that if I have the square root of 4 and I write it as 2 times 2, well, they're the same thing. And since I know the square root of 4, this just becomes 2. Well, it's the same logic, but just with the variable. If we were to change x to 4, I bet the answer would still be 4, because 4 squared is 16, and the square root of 16 is 4. So in this case, we have a couple that's going to go outside the square root. We know the square root of x times x. It's just going to be x. And since there's nothing left inside the square root, we don't need it anymore. See, back with our number example, because we're a little more familiar with numbers, we had the square root of 4, which would be our x squared. And we broke it down. We said, well, we have 2 times 2. That equals 4. Well, what we did over here is we said x times x equals x squared. And since I had a couple of 2's, I could clean that up because the square root of that would just be 2. So whenever you see square root of just squared, you basically just get rid of everything and you're left with x. Does that work all the time? No. But in this example, it did. Here we have x cubed y to the fourth that we're taking the square root of. So we have two variables this time. Again, I'm going to go ahead and write everything out the long way. It's also referred to as the expanded form of exponents. So x times x times x, and then I need 4y's. I don't have to write the multiplication dot because we can assume it's multiplication. Whenever you don't see an operation, it's multiplication. And I don't need to keep writing all those dots. I'm good. I don't want to waste my digital pen here. Now, again, using the phrase from before, couples go out, singles stay home. I have a couple of x's here. I have a couple of y's. And I have another couple of y's. Well, when I count it up, that's one x coming outside, there's a y coming outside, and there's another y coming outside. And then all you have to do is look to see who stays home, who didn't get circled. And in this case, we have one lonely x that stays home. See, the reason when we pull the two x's, when we take the square root of that and pull it out, just like before, you have two of them, but you're taking the square root of it. You can think of it like a square and you know the area, but you only need the length. So you only need one of the numbers, and they're going to be the same. So when we take the square root of x squared, or x times x, we just get x. And when we take the square root of y squared, we just get y. But we do it twice because there's two groups. Now, a little pro tip, if I'm your teacher, I would take this answer. I'm pretty flexible. But a lot of math teachers and even some state exams, they're going to want you to take it to the next level. So to do that, what you're going to do is you're going to keep pretty much everything the same. But you see how you have y times y? What they're going to want you to do is make that y squared. Now, mathematically, these two answers are not different. They are the same thing. It's just representing your answer in a different way. And I know a lot of teachers would prefer you represent your answer the way I've boxed. Again, I don't really care because they're mathematically the same, but let's go with what's going to be a bigger preference. Let's do one more example. So here we have simplify the square root of h to the sixth y w to the third. Okay, so again, just like we've been doing, we're going to break it down and write everything out in expanded form. I'm going to need a pretty big radical here. So we need 6 h's, 2, 3, 4, 5, 6. I need one y, and then I need 3 w's. W, W, W. All right. Couples go out, singles stay home. So here we go. I got a couple of h's there. I got a couple of h's there. I got a couple of h's there. I got a couple of w's, and that's it. So we're able to pull out 1h, 2h, 3h, and a w. And staying home tonight, we have a y and we have a w. And again, I would take this answer, but let's take it to the next step and let's clean it up. Since we have 3 h's, 1, 2, 3, we can write that as h cubed. Just one w on the outside, so he'll just be w. Square root of y w. And that would be the professional way to write your answer. Okay. Well, thanks for watching.